Hi, everybody, and pleasant evening from Tel Aviv, Israel. Happy to have like a nice global audience with us today. Happy to have Vinny today with us from CircleCI, rocking his beat with all those guitars in the background. Personally, I'll give like 2 minutes about my background. I'm currently VP of Product Management and one of 3 co-founders of Bridgecrew. Early stage startup, just raised our round A battery ventures company. This is one of our first webinars kind of exposing and walking through what we do. So I'll be interested in hearing some of the feedback from our audience today. Obviously, talking together with Vinny about the opportunities in automation around CI/CD pipeline security. Vinny, maybe a few words about yourself.
Yeah, sure. Thank you, Guy. So as Guy and Peyton introduced, my name is Vinny, and I'm a solutions engineer with CircleCI. I work with the salespeople on the pre-sale side to do demonstrations, a little bit like the one we're going to give you today, and talk to customers about CircleCI and what we do. And so, yeah, happy to be here.
Great. Yeah, so let's maybe dive right in. We'll probably go a little bit back and forth between Vinny and myself, but just to introduce our agenda for today. So pretty quick overview, about 30 minutes to give you the gist about what Bridgecrew, CircleCI both respectively do in this space around CI/CD and CI/CD automation. And hopefully some interesting demos to get us all going and really to see some of the value proposition that goes behind some of the technology that's in use here, and hopefully leave a proportional amount of time for questions at the end. So please feel free to send them through the Q&A section. Nice. So let's maybe give a quick brief on what is Bridgecrew. So Bridgecrew is a cloud security automation tool founded, I told you, about 18 months ago, I think. With the mission to simplify cloud security. And what we do is essentially 3 things. We help our customers find cloud issues in their build time and runtime environments. And we focus on cloud native environments, the entire stack from infrastructure as code, all the way to the runtime providers in the main 3 cloud providers. We're unique in the sense that we tap into the entire CI/CD pipeline, and we try to provide alongside the visibility into the issues that come with a growing cloud environment to really focus on resolving and fixing the issues as part of a developer lifecycle. And very early on, we found out that fixing is probably going to be our mission in today's cloud ecosystem. And I think that really got intensified in past 2-3 months with obviously work from home and people getting much more into cloud and digital transformation. So eventually down the stack, we deploy also in version control systems like the ones mentioned on this slide, like GitHub and GitLab and others. And one of the main focuses that we have today is to distribute some of the information and knowledge we can provide about security issues across the pipeline through automation. And CircleCI is a great partner in that sense, where we can utilize the workflow automations and pipelines within CircleCI and other CI/CD systems to really ensure that our developers get the information about the security of their configurations as fast as possible, and not after the fact once they get deployed into production environments. And we utilize a technology or a set of technologies that employ what we call policy as code. It means that we write every rule and configuration check in Python using a variety of open source solutions, including our own open source solution called Chekhov, to ensure that anyone can get the visibility they need across their stack. So policy as code, super interesting concept. We'll drill down into the works of how it really manifests in a CI/CD pipeline further down this talk. To you, Vinny.
All right, awesome. Thank you for the quick introduction, Guy. So kind of tagging along with Guy here and talking about CircleCI, what we do is our mission is to make it as easy as possible to go from idea and delivery. And we do that through our CI/CD tool. So we were founded in 2011. We're now at more than 340 employees across 5 continents. We're trying to get to 7 continents, but there's a lot of competition in Antarctica. So there's a little bit of a, had a little bit of a hard time there. We basically just help teams build better software faster, and we do that through the world's largest shared CI/CD platform. We run more than 1 million builds per day on our platform, and there's a lot of customers who love to trust us with their mission critical pipelines. Down below, you can just see a representative selection of logos who have decided to trust us with their mission critical processes and pipelines. Now, moving forward, where does CircleCI sit? For anybody who may be unfamiliar with CI/CD, CircleCI sits kind of in the middle here. Upstream, you've got your code and collaboration tools. People make commits to source control, and what that does is it triggers builds in CircleCI. Here in CircleCI, we are doing various different kinds of workloads, including the work that Bridgecrew is here to show you today. And we also have other people who are doing, typical builds of their Docker images and applications. They might be generating documentation, etc. There's a whole bunch of different things that you could be doing. And then finally, when all of your work is done, when the tests are good, everything is working, we finally ship to production. And in this case, we, because of the way our platform is architected, we support a variety of different integrations and places. And so you'll be seeing that here in a second in a quick demonstration. So if I flip over to here, when I go to my commits on GitHub, you can see here that I just made a commit recently that broke something, and this is problematic, right? And so when you click on the link, you are taken to what's called the job details page in CircleCI. In the job details page, you get a rundown of all of the different steps that we're running inside your job, which is the atomic unit of work here. And you can see that you're immediately given the information that you care about as a developer. I can see here that, hey, running the test cafe tests is exactly what failed. And so I can just check and see exactly what it is that I need to fix and do my work here. Now, the way that you get this kind of configuration is via the use of YAML inside the repository. If I do a command here, you can see that there's a .circleci folder inside the repository. Let me make the text a little bit bigger here. So there's a .circleci folder inside the repository, and then in there you have a configuration.yaml. And here is where you write the configuration for your jobs. So if I go to job definitions here, and then I take a look at this section, you can see that all of the steps that you see inside the job here are what you write inside this YAML configuration. Aside from spin up environment and preparing environment variables or secrets, which is common to all jobs, the rest of these steps are steps that you define as you want to inside the YAML configuration. We have special functionality, which will have special keys in YAML, but aside from that, the majority of your steps are going to be with this generic run command. And so on top of having the freedom to define your execution environment, which is going to be the first portion of your configuration, here you have a choice between Docker images, you have a choice between the major operating systems, Windows, Linux, Mac OS, etc. And you can also use your own custom Docker images if you'd like. You then also define the steps that you want to run inside the environment. And so because of this fine-grained control over both the environment and the dependencies, and the commands that you run, you can essentially integrate with almost anything, any other tool out there, as long as it has an API and it's reachable via the internet. And so that is one of the things that is really flexible and powerful about our platform. And that is also how we are able to partner together with providers and partners like Bridgecrew. Now, to kind of cement that in, this configuration right here that you're seeing, we have released a feature for this and to make it even more powerful, and that is with a feature called orbs. So orbs are basically just reusable, shareable packages of CircleCI configuration. And so what this means is that this configuration that people write to integrate with certain tools, to integrate with this platform or with that platform, you can take that, you can remove the secrets and sensitive information, turn it into a parameter, and then essentially reuse that and then essentially plug in your own secrets and tokens and use it almost like it's a function in code. If you take a look at this here, all of the configuration that I just showed you that configured that job to run all of this can be parameterized and then reused. You can reuse individual commands that do specific things. You can reuse the entire environments that you configure. Maybe you might want to standardize processes across your company or across all of the teams in your organization. And then finally, you can also reuse entire jobs. For example, sometimes the entire process is pretty much the same thing. The only thing that changes is maybe just the source code itself or a couple other parameters. And so you can parameterize an entire job and just reuse all those steps. All of this gives us the capability to really powerfully, flexibly, not have to write a whole bunch of YAML doing the same thing over and over. You can reuse and templatize across all of your teams, all of your projects, and across many organizations. Just as an example, we have lots of organizations using the AWS S3 orb, AWS ECR, AWS EKS orbs, etc. And so kind of along those lines in regards to integrations, this is what allows us to help and work with our partners to implement best practices in DevSecOps. Because now more than ever, cybersecurity is extremely important, right? As more and more of the world moves its materials and work online, especially with recent turn of events in the world, as Guy mentioned, more and more people are now staying at home, and we are starting to see the value of cloud services. It's more important than ever to focus on security. And so with all of these different steps, security steps inside the pipeline, you've got, let's see here, you've got your container scanning, you've got dependency and vulnerability scanning, you've got your static, dynamic, and interactive application security testing and secrets management. All of these are tools and partners that we have, and Bridgecrew is especially one of our favorite partners for infrastructure scanning. And so with all that being said, that's a quick introduction to CircleCI and how we partner together with other companies in the ecosystem. Now I'd like to hand it over to Guy to talk about Bridgecrew. Guy, I think
you're muted there, Guy.
Yeah. Thank you, Vinny, for that great setup. I'll actually pick up exactly where you stopped, and thanks for those kind words about our partnership. So I want to maybe spend 3-4 minutes to take a step back and to really talk about how a modern cloud native pipeline looks like. And I've been going back and forth between Bay Area, Silicon Valley, Tel Aviv as a tech hub, East Coast, past couple of years. And eventually, I think what I saw the most is this type of setup. Obviously, AWS being predominantly the main cloud provider used by most tech companies that we've worked with a secondary cloud now picking up in past maybe year and a half, with Azure and Google Cloud really stepping up with feature parity and obviously with cloud economics in mind. And really seeing CircleCI utilized actually internally at Bridgecrew and at most of our existing customers as the preferred system to build out both their software compiling and deployment into the cloud, and also everything that goes into the management of obviously testing and seeing that every piece of code is really sent to the right place before it gets shipped into production. Before that, we've seen predominantly GitHub used, obviously, as a centralized GitHub repo, version control, and centralized location to put all your in-progress development files and folders. And when it comes to the code that builds the cloud, actually, there's no doubt in my mind that I've seen Terraform probably most utilized across our customer base and the prospects that we've talked to. And when you zoom out and look at this pipeline, you can maybe find and replace or switch a few of these technologies. Obviously, go for a bigger company with multiple clouds or multiple infrastructures, code languages. But eventually, there is a layer of activities around security, which all have one thing in common. And I won't go into each and every one of these in particular, but when I look at some of these activities that go into building a secure CI/CD pipeline, I'm seeing one thing, and that thing is that every single activity here is eventually owned by developers, which, coming from almost 8 years in the industry, seeing that is for me like a very drastic change. Used to, security being something that's either compartmentalized and centralized and maybe more leaning towards physical and IT. Seeing so much of these security activities and security responsibility getting transitioned into the hands of developers and engineers is something that I think really is probably the secret sauce to some of the bigger companies that we've seen being able to grow fast in the cloud. And you can practically take these elements and maybe expand them, maybe zoom into them a little bit. But definitely, when I look at CI/CD security, what I personally see is a lot of activities that eventually fall under the broad shoulders of developers and engineering organizations. And that's been one of our early observations in this space. And really, when trying to build the foundations for Bridgecrew, we try to really figure out what is the workspace and how does the day-to-day life of infrastructure or cloud infrastructure developer looks like, and how can we eventually put ourselves in their shoes to build the best type of security platform that they can use. And specifically, we found infrastructure as code as an area of interest for two reasons. One, just the adoption. So when we looked at Terraform adoption over the past couple of years and how it's become probably a very common language to build resources in the public clouds, definitely saw the opportunity for us as a company both to build on Terraform and to provide an extra layer of protection for customers using Terraform. And this sense that something big is happening in Terraform really got enforced in the last 8-9 months when we started to schedulely scan the entire Terraform registry open source repository to see what are those building blocks looking like when you scan them individually, and you try to see if they're actually following the best practices laid out by Center of Internet Security and cloud providers themselves. And the results were pretty staggering. Pretty quickly when we looked at things like EC2 instances and S3 buckets and those very modules that build some of the biggest cloud environments in the world, modules with millions of downloads, we found a huge percent of them, almost 50%, contain some kind of misconfiguration. And I'm not going to go into each and every one of them, but we actually used an open framework that contains all the configuration checks that we run against it. And you're welcome to check it out under the Bridgecrew open source directory. But pretty staggering results. Many very widely adopted and used modules just contain, are not aligned with the best practices, and definitely some of those behaviors that eventually we see downstream when these building blocks get pushed into production. And the other side of this was also interesting, is for companies that had a hybrid model where configuration was either managed through infrastructure as code and was cooperating with a set of infrastructure that's legacy that was originally created either using the AWS SDK or manually through console. That's where we see the biggest impact of that, because suddenly new infrastructure can very quickly get provisioned and fixed, but all of that legacy footprint, if it's not managed as code, will never get remediated and fixed. And that drastically increases the likelihood of a potential misconfiguration, and obviously the fact that it's much more difficult to manipulate or to change a configuration that's already running, already in production. Definitely gave us motivation to start to find a way to try to solve this problem from end to end. And what does a Terraform misconfiguration look like? It's really in plain sight, but sometimes you have to really pinpoint it to try to understand. So I took a very popular Kubernetes engine module, and you can see maybe two misconfigurations right off the bat. You probably, if you work with Kubernetes, you know that using the kube dashboard is not a very sound requirement, not a very sound feature today. It could potentially expose an external actor to access your clusters. And also, obviously, not using your embedded RBAC controls is something that you shouldn't be following. But other than that, there's actually a wide array of explicit misconfigurations that, if they are not really lined out or spelled out as part of the resource definition, there's no way for definitely a junior developer to be able to identify those misconfigurations. And these are all guidelines and best practices that you would expect your developers to be following if you want to make sure those Kubernetes clusters are actually hardened. So bottom line is that, these misconfigurations are in plain sight. Some of them can be very easily mitigated by a simple switch of a single binary attribute, but some of them really require some more detailed inspection into code. And if you're interested in how more misconfigured modules look like, you should definitely check out a project called TerraGoat under our open source directory that contains a bunch of these types of vulnerable by design configurations that really help as a learning tool to emphasize to developers across the stack of how misconfiguration can really lie in plain sight. Let me just give maybe a quick overview of how the Bridgecrew process works before we jump into a demo. So we deploy very standard stack. So it's actually a process that goes in two ways. Our obviously hosted environment, SaaS delivered, self-service. You can sign up with your work email or Google account or GitHub single sign-on, and basically tap into two areas. One area could be your CI/CD pipeline, and here you can use native integrations we have with CircleCI and other CI systems, but also through official marketplace integrations to tap into your VCS, to be able to really tap into those configurations as they're getting committed into code. The other side is on the deployment and operation side, where we tap into the main cloud provider and also to Kubernetes workloads to conduct the same type of analysis, identifying misconfigurations, both in build time and in runtime, using a single policy as code framework. So essentially, you sign up to the platform, we run the policies framework, the policies code based on a standard schedule. And whenever we find a configuration that's drifting from best practice, you get notified. And where do you get notified? Hopefully in the places where your developers are actually doing the work. So when they commit a new change into a Terraform file and it contains a misconfiguration, it's pushed back to them as part of their GitHub pull request process. And we see that in the demo. If they're managing some of these jobs as part of a CircleCI workflow, you see that as part of the pipeline report. And if all those checks failed, or you're not able to run some of these integrations in your build time environment, you can definitely capture them in runtime and have them sending out notifications to your Splunk, your Slack, your Jira to notify you when a configuration was manually introduced into your runtime environment. And by that, we're starting to get the picture of how we can start to see the misconfigurations where they come from. But where it really starts to get interesting for us is when you look at fixing. This is what maybe I should focus on in a quick demo. So let me drag in Bridgecrew console. I think I have about like 5 minutes. Let's really run through this fairly quickly. So what I did is I logged into bridgecrew.cloud, signed in using my Google single sign-on, generated a new organization, and from this point forward, I'm in. And I have two options. I can either start to deploy and connect my cloud configurations using CloudFormation stack. So definitely one of the simplest deployments I've seen. We select the cloud provider that we want to use. When I click launch stack, I get diverted into the AWS console to build out a CloudFormation stack that basically generates a Bridgecrew read-only access role that enables Bridgecrew to start polling APIs using metadata only and the common security advisor role to start building out that configuration state manifest of the account. You can also use a Terraform template, by the way, to speed up that process. On the build side, I can tap into a GitHub account or a GitHub repo, select where I'm currently pushing all my configurations, and start to pull those into the environment. In this setup, I actually also integrated CircleCI, and I'm using the CircleCI orb, which is our preferred method to integrate to CircleCI. So it was very straightforward. I generally create a subscription, paste in my API key as part of an environment variable, add this to the configuration, the config YAML that Vinny displayed, and from that point forward, I'm able to tap into everything that's going through my CircleCI projects and definitely getting that telemetry back into the platform. And from the point where we set up either a connection to our cloud, to our VCS, to our CircleCI, or any one of those. If we have all three, great. But even if we have only one, we start to see some of these incidents piling up. And when I pivot to my incident view, you can start to see some of these misconfigurations getting aligned and getting found in real time. So if I really only zoom into this demo account that I set up, zoom into just a fraction of the misconfigurations, you can see that AKS Terraform template that I did put in my environment, and you can see that it's really found some misconfigurations across the stack. When I open up my search to see everything that it found, I can see that it really scanned only one AKS file and flagged those for potential remediation. And what's cool about it is from this point forward, I can either sit back and wait and see if my developers are resolving this, or I can actually invoke the remediation directly from here. But what I want to do is go to the developer's view and to see the issues from their own eyes. They're not really aware that I connected my Bridgecrew account into AWS. They're not aware that I have it here inside our GitHub repo, also protecting us. And when I look at a pull request, I can see some of this in action. So you can see a commit that I did about 4 hours ago to push in a side branch that I have that contained a few files, that AKS Terraform file and a few others. And you can see that these checks, this pull request eventually failed as part of our automated CircleCI build process. And when I want to go and see what really happened, click my details page, get pivoted into my CircleCI workflow view. And I get this very concrete snapshot of things that have gone wrong in my account. And you can see that I get this report about these failed checks. So I get this single Kubernetes cluster that failed, did not contain the network policy configured, and you can see it's not configured here. But it did pass some other check, which is nice. But the fact that these checks didn't pass get surfaced both for me as a developer as part of my GitHub evaluation process, but also as part of my evaluation process in CircleCI. So I get all that information in-house, and I can actually go back and see this entire history of my build and everything that Bridgecrew has looked out for me here in the past. I can also see successful additions of an S3 bucket that Barak, our CTO, did for me a few days back. And definitely I can go back and see those reports here as well. So common denominator for all of these eventually is the fact that instead of going and chasing a Jira ticket, which is nothing wrong with it, I can definitely now use this insight in order to understand whether or not I should remediate these issues. And from here forward, I can just simply go back into either my GitHub account or actually invoke a fix from Bridgecrew and start to see some of these violations getting resolved. So back to the operator view, if I turn on a few of these, let's take that S3 bucket as an example. So let's take an S3 bucket that, for example, let's see, it doesn't have encryption at rest. So you can see these are all part of a buckets that are currently misconfigured in runtime. I have the selection of invoking Lambda function as part of a playbook that will fix this in runtime. And alternatively, for Kubernetes manifest, excuse me, S3 manifest, I can look for something like S3 should have data encrypted at rest. Look for a Terraform file and see that this S3 TF file did not contain the encryption at rest argument. That's why all of these runtime buckets failed, and these buckets also modules did not go out as planned. So I can definitely go click remediate and open a pull request into this GitHub repo with this fix in line. So also a manual remediation step versus that automated prevention that we saw as part of the CI/CD workflow. And with that, and trying to be mindful of also time for questions, I'll stop here actually. Hand it over to Peyton. Hopefully she's still listening in, and yeah, and go from there.
Cool. Thanks, Guy. Thanks, Vinny. If you have questions, please put them in the Q&A panel here. I did want to mention also that we will be sending out the recording of this and the slides, so you can reference that demo. I know we're zooming through this. So I'll give people a second to ask some questions. We have one, which is, what are some of the most common misconfigurations in Terraform or otherwise that you see? I guess, Guy, want to take that one?
Yeah, sure. So you know what, we analyzed about 2,500 models to date with tens of thousands of files. I think where we've seen most misconfiguration attributes are around 3 areas. So first is actually logging and auditing, where a lot of these modules are probably getting built in a functional mindset and don't include the embedded monitoring and logging options that you get when you deploy them. So things like access logging for S3 buckets, monitoring logging for your managed Kubernetes services across the 3 providers. Those are definitely missing across all categories. Another important element is encryption. So we're seeing a lot of database modules from the popular ones on Amazon, RDS, Elasticsearch, S3, of course, just not including the encrypted argument by default, and thus creating obviously headache for someone that has to come maybe a few months later and have to migrate all of those into an encrypted bucket. So that was also something that we saw missing across the stack. And another big element has been Kubernetes. So managed Kubernetes has been an area of focus for us personally. And we found, compared to, for example, the Kubernetes benchmarks, which are pretty extensive, quite a lot of the modules out there that are trying to simplify managing those managed Kubernetes services across the providers, Google's Cloud Engine, and obviously AKS, EKS, Azure, and Amazon. Obviously, all of them containing some of the very fundamental misalignments with usage of fundamentals across network policies, usage of admission controllers, consistent hardening of Docker images. All of those are actually misconfigured practically everywhere that we looked on Terraform modules, and other places were actually in pretty good shape. When we looked at things like networking and IAM modules, we are very happy to see that fairly most of them contain basic and sometimes even advanced best practices.
I have to do a little plug here. Everybody that's still here, look out for some of this research next week. We have some exciting stuff in store that I think this audience will find very interesting. Back to questions. This one's kind of long. So there's lots of tools in the DevSecOps space. Seems like there's a struggle between doing things quickly versus doing things well. Can you expand on the current weaknesses of these tools and how they're being used? Specific examples, etc.
Vinny, do you want to take first crack at it?
Yeah, I guess that was kind of a very general question, and so I mean, there are a lot of different tools out there, and so I don't know if like doing a rundown of like strengths and weaknesses of every single one of those tools is a good use of the time here today on this call. What I will say is that generally speaking, if you want to do research on these tools and see what the strengths and weaknesses are of them, I would definitely encourage attending webinars like this one, where people actually walk through demonstrations of the product, show you how to use it, etc., and show you the features of the product. That way you can fairly compare how certain things are better in one tool versus another tool. To be fair, yeah, it's a true statement. The software landscape is becoming very saturated with these DevOps tools, and so you definitely want to pick the one that is the best for your team and your use case. So,
Guy, anything to add?
I'll say that I'm encouraged of also being part of a wave of companies that are trying to solve some of the more advanced problems in this space, and trying to keep pace with the rapid developments and changes in how code and software gets delivered in a cloud environment. So personally, being someone that's more tech savvy and like an early adopter, I find that actually is something that's remnant of understanding that we have a problem in how we ship secure code, and personally I found it as a huge opportunity to experiment and to find, as Vinny said, the things that are right for your team and the way that you build your stack.
Cool. Speaking of tools, we have a question, sorry, Vinny, about Jenkins. Can I integrate Bridgecrew with Jenkins? And what's the difference between CircleCI and Jenkins?
So the first question, I'll let Guy answer. Actually, can you integrate Bridgecrew with Jenkins?
You could. It's a slightly more manual process. It's actually documented on our docs. You have to create a new pipeline, figure out if you want to use the JUnit XML format. So slightly a little bit more work in terms of streamlining it into the process.
Okay, gotcha. And actually, that's thank you for answering that, because that actually kind of aligns with what I was about to say. And so, yes, technically speaking, Jenkins is, it's a great tool. It's been around for a very long time, and it fulfills a lot of requirements that people have, because you can kind of hack at it and kind of configure it to have it do whatever it is you want it to do or need it to do. It's like the Swiss Army knife of CI/CD tools, right? And so where CircleCI comes in is that, number one, we're a fully cloud managed tool. And so whereas in Jenkins, you have to configure your build machines and then install the agents on them and then connect them back to the primary server, and then you have to set up all your plugins, you need to set up all your webhooks for all your repositories, etc. You don't have to do any of that on CircleCI. On CircleCI, you want to onboard a project, it's just a click of a button. If you want to change the configuration for a certain job, it's just changing that configuration file in the repository. And so you can track your pipelines like you do the rest of your source code. And that's really powerful, because then it means that if a pipeline breaks, you can pinpoint, what broke it, when it was broken, and things like that. And in addition, we, because all of the infrastructure is managed for you, we are really built to scale. Some of those logos that you saw in one of the first slides that I showed you, some of those customers are running some crazy number of builds. I mentioned before that we're doing over 1 million builds a day, and that's because some of these customers are doing 1000x, 2000x parallelism and concurrency on our platform. And so trying to configure that in Jenkins yourself is a total pain, and it's very painful because you have to do a lot of that manually. Maybe there are tools out there that have automated that process a little bit, but you still have to take charge of some of that yourself. And so with CircleCI, it's all set up for you. It's ready to go. You don't have to deal with any of that. And in addition, because of the way our platform is architected, you have the ability to create orbs for partners like Bridgecrew, so that you don't have to, hack in this functionality in the pipeline yourself. So hopefully that answers your question there.
And a good follow-up here, another question, as someone new to CircleCI, would you say using an orb in this scenario with Chekhov would be the best option? If so, how would one ensure teams are using the orb when building their infrastructure? Guy?
Yeah, definitely one of the scenarios that we see most common. Most often people try out Chekhov and definitely try to understand what are the best usage and scenarios to integrate it into their pipelines, and then select to integrate it into their runtime or other built-in components. So it goes back to the question of manageability. The benefit of an orb in this case is that we help contribute to the fact that it continues to update Chekhov. So one of the pains with a tool like Chekhov, which is obviously CLI based, and you can invoke it and run it manually as part of a pipeline, or even on your personal workstation, is that you don't gain the benefit of the fact that it's constantly evolving. We had policies probably on a daily basis. We've added 3 new additional configuration frameworks just in the last couple of weeks, with ARM templates, serverless framework, Kubernetes in the beginning of June. So pretty rapidly growing pace of feature expansion, and the benefit of an orb in this case versus a standalone what we call a CLI integration, very similar to the one you can hack through Jenkins, is the benefit of getting that constantly updated and upgraded, and just get better visibility to its uptime and how much resources it's utilizing as part of the build process, if that's something you're conscious of. And that's where I think CircleCI specifically does a good job in letting you know if your testing scenarios are actually cost efficient and are not just wasting a lot of time running on blend. So hope that answered the question, but
cool. Well, we are just about at the 45-minute mark. I think that was fantastic. And thanks everybody for joining us. This is, as Guy said, one of our first webinars. And also, as Guy said, we are building new stuff all the time and really excited to get feedback from you guys. So feel free to respond to our follow-up email or reach out to any of us on Twitter, or you can send us an email at info@bridgecrew.io, and we look forward to hearing from you. Have a great day and talk to you later.
Thank you, Peter.
Thank you, everyone.
Thanks, everyone.